All right, good afternoon, everyone. So we are going to complete our discussion about exceptions today. For those of you who are following along with the slides, there is a section in here on assertions. We're going to delay that to next week because it has more to do with testing than it does it's part of exceptions, it's part of error handling, but it has to do with, I want to push it back to the testing discussion next week. All right, so, but first, as always, let's see which.
Yeah, I think you close your microphone.
How did that happen? That's weird. Okay. So, quote of the day, Gordon Moore, who died last week, passed away, unfortunately. He's where we get Moore's Law from, which he stated that every 2 years, the number of transistors on a chip would double, but in actuality, it's more like 18 months. But it has held pretty steady, which is why when I was your age, we had thumb drives that could hold 128, 256 megabytes, and now we are able to hold so much more on such a small device. But this quote I did use this once before, but I do have another one from him as well. It's just kind of the same idea, which is if everything you try works, you aren't trying hard enough. Basically, again, engineers, we are not afraid of failure. Okay, we are not afraid of failure. What we are afraid of is not trying. That's what we don't want to do. Right, what we want to do is we want to try something to see if it can work. If it doesn't, we learn from those mistakes so that we can keep going, which is, again, kind of connects back to yesterday's discussion where we started talking about exceptions. Because throughout your last semester, every time that you got a runtime error, every time you got an error in your code, you tried to figure out how to fix it. Right? You tried to, it's like, how can we get rid of this error? Errors are bad, but we want to get rid of them, right? But in actuality, sometimes we want to have an error occur if a bad input comes our way, right? We can create our own exceptions, which we will talk about as well, of how to create our own exception classes. Remember that an exception is an object. It's a class, just like any other object. We can create our own. All right, let's see. When do we want to throw exceptions? Okay. Sometimes we want to throw an exception if an error is there, right? But sometimes if we catch it, if we're just going to catch it ourselves, it might be easier to not throw an exception. So this comes back to the question that can't remember who one of you had yesterday about the null pointer exception. So here we can have a situation where we try to do something. If we are able to print the toString method of this, then it points to an actual object. It's successful and we just keep on going. If for whatever reason this is not able to, it could be that it points to a null value, so it points to something that doesn't exist. And then we would catch that exception and we would print this out, right? Now, I say that it would be better to do this, where if the reference variable is null, it doesn't point to an object, we print, or sorry, if it's not null, if it points to an object, I should say, we print out the toString method. Otherwise, if it points to null, then we print this out. Okay. I won't spend much time talking about this because I'll just simply say the reason why I say this is better, the reason why I believe this is better, is here This results in an error condition where a new object is created, an exception type object is created. The only thing it does is print out this string, right? This taxes the system a little bit more than this does. Okay, both of these pieces of code do the same thing. If the reference variable points to an actual object, it displays that to the screen, displays the object to the screen. If it's null, it prints out reference variable as null. This one does the exact same thing. Okay, so sometimes if we're going to handle an exception that is likely to occur, if we're going to handle that inside of our code, maybe just do an if else. Right? If, however, there's an exception that could occur that either we don't know about or we want to allow a higher method to take care of it, then we will throw an exception in that situation. Okay. Questions, comments? No. You say anything if you got any questions, all right? We can define our own exceptions. We'll look at an example of that here in a moment. Okay, and then as I said, assertions, we will cover this as part of the testing discussion next week. I want to reserve the rest of this time for some examples. Okay, so we'll talk about assertions next week, so come back for that. This is, was that, like a little reclam, right? An advertisement. Okay, and also as part of these slides, remember the file class was part of this chapter, and so that's why these slides, this can be a review for you. Okay, so let's look at some examples. Okay, so let's imagine we have a quotient method here, that's quotient class, and its purpose is to take two values from a user, right? It'll let me compile it. Come on. All right. All right. So it'll take two values from the user, and it'll display the result of dividing the first number by the second. Okay. So two numbers. Give me two numbers. Anybody? Zero and zero. You're getting ahead of the game here. Hold on. Give me two normal numbers. 13, and one of you put 7, so you hit 7 there, 7 geese. Let's do that. Okay. 13 divided by 7 is 1. That's not right, is it? Is that right? 13 divided by 7 is 1? What's wrong with our program? Ah, integer division, right. Okay, so let's give it 81 and 3. Ah, that's more like it. Okay. Now let's go back to Metahan, your examples, right? 0 and 0. Right, okay, so we get this arithmetic exception because we tried to divide by 0. Okay, now what we could do is we could say, okay, you know what? If our user decides to give, right, the second number as 0, we can just have an if statement that handles that situation, right? So here, if we run it, now if we give them a 0 and a 0, right, we display this message saying divisor cannot be 0. Right. We could also do a method, right, a quotient method that just checks if the number is 0, if the second number is 0, we cannot divide by 0, we exit. Be careful with this though, right? Remember we told you before, do not use this system.exit in your code because it can mess with our test cases, which would result in a lower grade for you. All right, so that's This is just an example of how you could do this in normal programming practice where not for this course, right? All right. And then finally, we could do as an exception, right? Basically, this does the same thing, right? This does the same thing as this one back here, where it generates an exception, right? But we catch, in this time, instead, we catch that exception as part of our method here and do something with it. Now, why would we want to catch the exception? Why would we want to allow for a divide by 0 to be caught? Well, let me help you look at this here. Okay, here's an example that's using integer division, the same as above. Okay, where I've defined this thing called a class average, right? And it's going to get however many values I'm giving, right? So however many students there are, I am going to get that many values. I'm going to total it up, and I'm going to divide the total by the count, by however many students there are. Okay. Now, my get value method simply displays out to the user which value we should be getting and returning whatever they enter the next integer. So I'm not going to go into too much of detailing of what's going on here, of why this is a scanner object being passed through to my lower methods. All that was covered in 101. So go back and look back to 101 if you want to know why this scanner imp is going on there. Okay. All right. Now, there's no catching of exceptions, but if I go to run this, okay, if I say for the class 1, for the first class average for 5 students, so I should enter 5 values. So let's give it, what, 10, 8, 10, 9, and 7. Exception. Okay, well, it showed me the class average is 8. That's fine, whatever. But what happened here? Why did it get an exception? Didn't even ask me for one value, right? Let's take a look. So as we step in, all right, we're going to get the value from the user. All right, so now we're just going to wait. We're going to give it the 10 here. What did I say, 8 before? Oh, I said 10 before, I believe. Let's give it 10 again. Okay, it's waiting, so let me give 7. I think that divides by 5. Oh. All right, now it's going to return the value of my total, which was 10 plus 10 plus 10 is 30, plus 15 is 45, divided by 5 is 7, right? Nope. No, 45 divided by 9. Right, class average 9. Good, yeah. So now I'm going to call the same method, but with 0. That shouldn't really make any sense, right? You cannot calculate a class average for 0 students, right? So let's see here. All right, so it does this. Then what? Now what? It never went into the loop. Why did it never go into the loop? Why did it never do this? Yeah, because I is 0. Count is 0. 0 is not less than 0, so it's already done, right? Okay, so then when it tries to calculate this, I get that exception, right? As we would expect. Now, the reason why we might want to catch an exception, right, is what if I still wanted to do this? What if I don't want to have to, if this is bad, that's fine. Okay, that's fine. I can't calculate a class average for 0 students. I get it. That's fine. That makes sense. But what if, even if this is bad, I still want to do this too, right? So what we could do is we could say, okay, in class average, if there's an exception, and we're going to catch arithmetic exception. There's an arithmetic exception. We're going to display so now we can still all right. Oh, missing return. Guess we still got to return something. Okay, so 10, 10, 7, 8, 10. All right, and then we let it know that an exception occurred, but we can continue on doing the rest of our work. We don't have to stop doing our work just because one of our examples had an exception in it, right? So let's go 9, 8, 7. All right. Now I do want to point out something. We did this using integer division. A class average normally wouldn't be an integer, would it? Normally it would be a double, right? Return total divided by count, which is fine. And then our values would also be double values normally, right? Okay. But I want to show you guys something, if assuming this is no compiler errors, okay? Watch what's going to happen. Let's enter value 1. Let's make it 10 for the first one, 9.5 for the second one, 8 for the third one, 6, 3. Okay, so the class average for 5 students is 7.3. Well, watch what's going to happen when we do this one. It's kind of interesting. Okay, so count is still 0. Total, we're not gonna increase it, right? Because we're not gonna get anything. So what do you think is going to happen here? Do you think an exception will occur here? What's total? Total is 0.0. Count is 0. Let's see. Think about what you think will happen. Will another exception occur? No exception. So what's going to display? The class average for 0 students is nan. Nan. What does that mean? Anybody know what this stands for? Right, not a number, right? So be careful with this because sometimes, because see, in this situation, is this what we wanted to happen? Did we want class average for 0 students to be not a number? If our average user, if the average user saw this, would they say, oh, that makes sense? Probably not. In fact, I would imagine many of you in this class did not know what that stood for. Some of you didn't even know what that stood for until Conberg said it, right? So what we would probably prefer, what we would probably prefer is that if this happens, we generate an exception, right? That we give an exception for the purpose of saying, hey, no, this is a bad value. Okay, so we can either use the existing arithmetic exception. We could say here, very first thing. If count is less than 1, I'll say. Right now, the reason why I'm saying that is because 1. Well, let's show you what happens here. Let's see here. We could do a negative value. If we run this, the class average for -3 students is -0. Doesn't really make a lot of sense, does it? This is a bad input, but it gives us a legitimate output. That's probably not right. Okay. So what we're going to do is we're going to say, okay, if they give us a count that is less than 1, right, 0 or negative, then we're going to throw a new arithmetic exception, right? Otherwise, we're going to keep going, right? So now, let me debug this to show you what's going to happen here. Step over that. Okay. So here, count is 0. It's less than 1. So it's going to throw a new arithmetic exception, which will get caught here. So it skipped over all of this, right? It didn't do any of this because the exception occurred, which means it's going to go down to catch an arithmetic exception. Okay. We're going to display that an exception occurred. We're going to return 0. All right. Oh, okay. And then, oh, I accidentally skipped over. But the same thing happened here. When a -3 occurred, it tells me that an exception occurred. Now, that's probably not very informative, right? Exception occurred. What I could do is I could say, tell me what occurred. Remember that the arithmetic exception is an object, right? So EX is a reference variable that points to an object. So I could display its toString method. Let me do this. Let me also get rid of all non-error condition ones so this is a little bit faster. Okay. So we're going to throw the new arithmetic exception. It's going to come down to here. It's going to print out what the message is right? So, oh, an arithmetic exception occurred. Okay. But that might not be super helpful, right? That might not be very helpful. What we could do is we could say, you know what? I think it's what? Print stack. That I'm looking for. No, that's not print stack. It's. Oh, that's right. Print stack trace just does the printing on itself. That's right. It's not a value that gets returned. Oh, there we go. All right, so now when we go inside here and we get that exception occurring, we're going to print the stack trace, which is how did this exception occur? What process was followed to get to this exception? So the main method called something at line 7, as we see here. The exception occurred at line 15. Hey, this looks familiar, doesn't it? Right? We've seen something like this before, right? Exception name, green text with line numbers and calling and stuff. Where have you seen this before? Does this look familiar? Where have you seen this before? Has anyone seen something that looks like this before? Right. When you've gotten a runtime error before, you've seen something like this before, right? So like, let me think, let me go find out, let's see if I can find one up, like up here, right? When we tried to run this with just dividing, right? Without having an exception be thrown, we got that exact same thing, didn't we? It told us the type. It told us the thing here. So this would be a way that we could display the stack trace. We could display the information about how the exception occurred without having to end the program. Because watch, because the program is not over, right? We're still going on. We can still run more. We can get a new exception, right? Same thing as before, right? Okay. All right, so now let's see. Let's say that arithmetic exception, we don't like that. It's not descriptive enough. We want to create our own exception. What should we call it? So we're going to call it bad student count exception. Exception. Okay. Now, because it is an exception, we're going to have to tell our compiler that it extends from the exception class. Now, we can make it just a base exception. We can make it a runtime exception. We could make it an arithmetic exception. Any of these would be fine. But remember that what it extends from, it will be of that type. So if I were to make it an exception, it would not get caught by the catch arithmetic exception catch block. Okay, so if I make it an arithmetic, because an exception, it's a child of the exception class, it's not necessarily an arithmetic exception. So let's call it an arithmetic exception. Arithmetic exception. Right. Need to create a constructor, right? I guess we don't have to, but what would be a good idea would be telling our constructor what was the bad value. So by keeping a parameter, in here, it tells us what the bad value was, right? That way we can tell our user as part of an error message, string to string. I'm going to overload the toString method. Override rather. We're going to override the toString method, and we're going to tell our user what the bad value was, right? Okay. So now we can give our user more information about the error that they encountered. So now we can, instead of instead of throwing just a random arithmetic exception, we can throw our own type of exception that and then let's, instead of printing the stack trace, let's print out the message that we get. Okay. This should work. Maybe errors, but we'll see. Okay. So now when we give it a 0 as the value, count is less than 1, we're going to throw a new bad student count exception. Okay, that's going to create our exception class. It's going to go here, and now it's going to print out the error message that we got. Bad student count exception, count was 0. Right. And then the same thing here. When we pass it a value of -3, we create a new bad student count exception. Okay. All right, bad student count exception, count was -3. So we can tell our user more about what went wrong for the what was the invalid value that was passed. Oh, let me do one other thing here. Okay, oh. We could catch an arithmetic exception. Right? We could also catch exception. Right? So this is all going to be just fine, right? This should work. Right? So basically, remember, if it throws a bad student count exception, we experience this. If it's not caught here, it'll get caught here. If it's not caught here, it'll get caught here. Now, the reason why I'm bringing this up is because this compiled just fine. This will not. Why not? Why did this give me a compiler error? Why do you think? Right, because I have a catch arithmetic exception block here, that means that if this catches an arithmetic exception, it would also catch a bad student count exception for the same reason, right? Because bad student count extends arithmetic exception. Okay. If I take this off, that will get rid of my compiler error. Because now bad student count is not a subclass, it's not a child of arithmetic exception. Okay, they're two different ones, right? But it is a type exception. So if I move this one up here, now I'll get a compiler error again, right? Because exception is caught here. It's catching all exceptions. So if it's caught here, it cannot possibly be caught here. If it's caught here, it cannot possibly be caught here. Okay. So is everyone clear about that? Is that you understand why some of these are the way they are? So if we have multiple exceptions that could occur, right? I'm going to make this an arithmetic. If we have multiple exceptions that could occur, the lowest one, the most child one of them all has to be caught first. Then if there's a parent type, then it can be caught above that. And then if it's a parent type, we can be caught above that. Okay. Let me give you an example. Let me see. Let me give an example of I'm going to add to this lecture. We're kind of out of time here for today, and I don't want to take up the time for me typing a bunch of stuff here for this class. But I'm going to add to this example, and I encourage you to look at it during your time, right? During your off time outside of this class. I'm going to put an example that involves a method that has two possible exceptions that could occur, and then the calling method will catch both types, right? And so we'll see how that could occur. Okay. All right. Oh, yeah, no, we also got the not. I did do the not a number thing. Okay. Are there any questions about exceptions? Because your second assignment is going to involve you creating your own exceptions. So I want to make sure that you guys understand this and know what is expected here. Questions, comments, nothing? All right, well, we will end there for today. Thank you guys for attending. We will see, I'll see you guys on Wednesday of next week. Have a good afternoon.